técnica de Experto relacionada con reducción de partícula, llámese rompedores de terrones o llámese molinos en las diferentes tecnologías que tenemos, desde molinos estándar de martillos hasta pulverizadores y micronizadores, que son ya tecnologías más avanzadas. Entonces, pues les agradecemos nuevamente a todos. Vamos a hacerlo lo más ameno y aplicable posible. Y pues, JB, we appreciate you, all of us, for you being here in this time. And we're very excited to know more about lump breaking and milling technology, the latest and new technology that we can have for our processes. Thank you again.
Okay, thank you. Well, I hope everyone's here and everyone can hear me and also see my screen. Good morning, buenos dias. We're going to jump right into this and hopefully have enough time to answer as many questions at the end. Let's talk about our agenda briefly. We're going to talk about lump breakers, hammer mills, fine grinders, classifying mills, some of the technology that's used behind the screens and how to size screens. And then we also offer some screenless mills or rotor mills. We'll do a quick review and then we'll answer some questions. Lump breakers, very simple. These are low RPM, and when I say low RPM, I mean 260, 320 RPM. They'll take products from sizes of 0.3 meter all the way down to 1 millimeter. Excuse me, 1 millimeter. They have a single shaft or dual shaft design. They are basically designed to rotate and break up product that is already small or fine or powder. Sometimes what happens when you store in containers, silos, bulk bags, super saccos, that you have the product will compress and turn into larger pieces. And what this does is this will allow those products to, excuse me, those products to be returned to their original form. Okay. Obviously, for these units, the throughput is based on opening and screen opening size. So the finer the screen, the less throughput. These are not meant to do size reduction. These are not meant to take something that is a solid 6 millimeter and turn it into 1 millimeter. It is meant to break up already fine or granular products. So we rarely use it to we'll use it for things like sugar or salt or ammonium sulfate. So some chemicals, but meant just to condition. They really are designed to condition ingredients, also to eliminate off-spec products. The unit you see here is what we call a quick clean or clean in place, which is an option. And we offer these in single and dual shaft units. So the dual shaft units have a lower profile and will allow you more throughput. And the single shaft units are a little more aggressive or stronger towards breaking up those larger pieces. It really does reduce the amount of handling. We find that sometimes customers are force feeding through a screen some sort of bag of maybe pigment or fertilizer or anything like that, where they're having to push it through a screen in order to break it up. This will allow the product to just fall through. It'll break it up on its own and really kind of reduce the amount of time that you have to spend breaking stuff out of big bags or small. Where's a good place for a lump breaker? Well, good places for them is to delump before loading bags. Also to delump after unloading bags. Sometimes we will put these between a silo and a process in order to reduce the size of the product so that it will work in a screw or a pneumatic conveying system. And then also we want to make sure that we'll use them before blending. This will keep you from having larger chunks that are difficult for a blender to eliminate. So this will take the off-spec product before it goes into a blender and turn it back to its original finer, coarse powder before it goes in, so you don't have so much work from the blender. So those are lump breakers. Those in most cases do not do particle reduction. They do more conditioning and removal of agglomerations or buildup. The next thing we get into is going to be size reduction, and that's going to be our hammer mills. Now, this is impact milling. What I mean by impact milling is we use torque and speed in order to break or shatter a particle. Hammer mills are really good for coarse size reduction, sort of free-flowing bulk solids and friables. We use this for corn, mice. We use this product for other larger chemicals. It will work anywhere between 10 to 60 mesh, just depending on the product. If the product is already fine, sometimes a hammer mill will not work. But it is capable of shredding hard and softer products. In some cases, we've used a hammer mill with knife blades to cut bread or pun. So hammer mills we are able to set these up to work differently for different materials. The other good thing about hammer mills is the screen changes are very simple. Usually for our hammer mills, the screen changes are toolless. And then the other thing about hammer mills that are different than lump breakers is when we add additional horsepower, it will increase the capacity of a hammer mill. So if you have a hammer mill that is not completely maxed out on horsepower, you can add a larger motor and get a little more throughput without having to purchase a larger mill. Some things about hammer mills and how they work is mostly based on tip clearance. Hammer mills sort of live and die by where the screen and the mill hammer is. We always try to keep the clearances between 1 and 1.5 millimeter. Obviously, the closer the tip is to the screen, the finer the grind. And the further away the tip is to the screen, the coarser the grind. So at high speeds, if we're trying to get a finer grind, we will set the hammer tip to be a little bit closer. And then on something that might require a coarser grind, we will pull that hammer back in order to control how aggressive the mill is. Okay, some quick pictures of some hammer mills and some information on them. They're great at size reduction for grains, some chemicals. They help improve fine milling by pre-grinding. So as we get further down the line of mills that are more aggressive, that generate finer powders, polvo más fin, sometimes a piece is too large for a fine grinder or classifying mill, and we will use a hammer mill to make those pieces a little more manageable. And once again, they are easy to change this, clean the screens. I don't know if you can see this, but the door just opens up and the screen slides out. You don't need tools to change the screens. And then we can also set these up for completely sanitary and also for products that are more abrasive, like pet coke and other silica-based items. Another style of hammer mill is a mega hammer mill. And basically what that is the same hammer mill as we saw before, except it's a lot larger. These mills are meant to do metric ton plus per hour and a little bit finer. This is where you get closer to the 60 mesh, or something that's more like, excuse me, 0.2 or 1/4 millimeter. Once again, more precise grinds. We use a cantilever design so that you can actually access and service the unit without having to take it apart. You can also set this up with wear liners, also screen dividers that help with the grind. It is a full access front door. Right now I'm showing this with the door off, but when it is closed, it is airtight, and normally we ask that there be a little bit of vacuum on the bottom of this mill in order to keep the dust from escaping into the environment. So those are hammer mills. These are swinging hammers. When they say hammers, these things right here are the swinging hammers. In here you have a screen, you have some grinding segments and screen hold segments. The product comes in from the top, it makes it through the screen, is swept out from the bottom of this mill. Okay, so those are mostly the swinging hammer types of mills that we have. There's the hammer mill, what we call our G series, and our mega mill, and these are impact milling. Once again, these will take you all the way up to all the way down to about 60 mesh. Just depends on the product. Normally, if a product starts very small, like maybe it's already 2 or 3 millimeter, like a granule or a prill, sometimes hammer mills won't work because the material is too small to begin with. And so when we start working with those types of products, we start talking about fine grinders. Now these are once again impact milling. We use high-speed mill for fine powders. We use this for food products, chemicals, sorbents, grains. Most of the stuff that we do this for is low-fat, oil moisture content, not as abrasive, and I would say probably 99% of the time it's used in a pneumatic system. Once again, the working range is 300 to 200 or 30 to 200 mesh. So you basically have, this is one with the door off. The product comes in through the front, it's dispersed, and then these blades impact the product through the screen, and then the product comes out on the outside through the bottom. And I can show you another picture of that and sort of identify. Now this is what they call a rotor and stator setup. So a fine grinder will feature your body. This is your rotor with the blades. So these lines right here are actually blades. This is the rotor. And then the screen frame assembly is your stator. These blades are moving anywhere from 100 to 120 meters per second. So this is a very high speed mill. The bearings are mounted outboard, outside of the grinding chamber. Obviously we have a standard tipped key safety interlock system. It is a rigid frame. And this is where the inlet is. So once the door closes, you hook up your convey line and your product will go in here. All of our units work under vacuum and no pressure. Very difficult to work under pressure because that has a tendency to push the product against screens and keep them from working efficiently. So all of our stuff, most fine grinders, universal mills will work off of a vacuum. And then I want to talk a little bit about this piece, the multi-piece screen frame with grinding jaw. Here's a picture inside of the fine grinder. So we have what we call grinding segments or jaws. So these machined pieces right here are the grinding segments or jaws. And then this lighter gray area is the screen. So this is still where we're able to control what size particles can clear through this screen. So it does do what we call a retain overs until it gets an opportunity to be made to smaller particles. Different screen types, which we will go into, different screen types and orientations can improve grinding efficiency. We can also change the way some of these grooves are angled directionally in order to assist with grinding, and also with materials from machine steel to other materials that we use depending on how hard the product is. So that's what it looks like inside. So when you take the wheel, when you take this wheel off of here and you look inside this area, what you'll see is this screen and grinding jaw assembly. In some cases where the product is very friable, but doesn't require screening, we will actually run 2 sets of jaws and just a space between the 2 sets of jaws. So it's what they call a dual jaw assembly, just to get more grind, to be more aggressive. So that's the inner workings of a fine grinder, which brings us to our next piece of technology, which is our air classifying mill. Now this is very much like a fine grinder. A fine grinder is fed from the front. This unit is fed from the back, and we'll go over that. Basically, this is a high-speed impact mill. This will get stuff, a lot of powders down to 10 to 100 micron. So we're no longer talking about mesh, we're talking about micron. This is a high-speed impact mill. It is basically a fine grinder, but we have also added internally what we call a classifying wheel. And what this classifying wheel does is it spins at a certain rate in order to allow particles past. So the faster this wheel internally here spins, the smaller the particle size output. If you have something that a product that you are doing for regular customers that might be 100 or 120 micron, and then you have customers that want something finer, you can actually change the RPM on this wheel, which will change the cut of the product that comes out. So let's take a look at how it works, and it'll probably answer a little more of the questions that you might have. Unlike the fine grinder where the product comes in from the front, this classifying mill, the product comes in from the back. It still comes to the center and is used. There's the blades, there's the stator, this is the rotor. So it's still doing the same thing, but only coming from the back. And then once the product clears through the screens, it goes through the front, and you have the classifying wheel that we spoke about earlier. And the faster I turn this wheel, the smaller the product output is. The products that don't make it through the classifying wheel are then recycled or recirculated back into the grinding chamber for another pass. So we call this a recirculating or classifying mill, or air classifying mill. It has 2 motors. It's got a mill drive, which is usually on the larger side, and then it's got a classifying drive. Some of our larger units will run 250 horsepower on the mill side and 30 horsepower on the classifying side. Once again, it has a classifying rotor, has a hinged door on the front. So like I showed in the previous slide, the product comes in through the back, it's milled, it clears the classifying wheel, and it comes out through the front. So just a little different orientation because it's a different style. It's not a single pass like a fine grinder. It is a recirculating mill. So you can get more aggressive with your cuts. The other part of this is that the classifying mill will give you a tighter particle distribution curve. So if you need to be D98, 98% passing 325 mesh, you are going to find that this unit will give you less overs and less unders and have a tighter curve. So a bulk of that product is going to be just under 325. Part of that mill is also swept by a secondary air inlet. That mostly just happens when the unit is installed and we start tuning it in order to meet your customer specifications. Some information about those. Size inputs from 10 to 100 micron, online control of milled particle size, uniform grinding with narrow particle distribution. It does have a 2-stage closed circuit grinding, always standard safety features. And we offer 5 sizes from a 3 to a 250 horsepower unit. So most of these mills that you've seen right now work on a rotor stator or some sort of hammer or blade that is reaching a grinding jaw or a screen. And that's very important that we spend a little bit of time talking about screens, because screens can make or break what happens in a milling environment. So, you know, the sizing screens, so this is inside of a hammer mill like we spoke earlier. The size of the screens create retention, so it holds oversized product inside the chamber so that the mill can continue to work the product to the correct size. As particles accelerate off of the hammer and blade tip, they'll hit the screen surface, and sometimes they'll go through, and other times they will, for lack of a better word, ricochet back into the grinding area. As particles rebound in the path, the rotor at reduced velocities will get hit again, and we will continue to be doing that impact milling. Differential speeds can create more efficient secondary collisions inside the area, but once again, the screens are meant to keep the product from passing until it meets spec. Here's kind of some information on selection. You know, we basically select the screen on what the requirements are and what we have tested. We always recommend testing. If somebody needs everything less than 1/8 of an inch, then we will always select the largest screen that will give us 1/8 of an inch throughput. We try to balance the screens with the capability of the machine. So if it's a very close tolerance on the blade to screen, then we don't need a large hole screen. We need something a little bit finer. And then we always try to use the screens that we currently stock. We try not to get fancy and make something that will be difficult to source later. So that's really how the screen system works. So here, once again, in the hammer mill, we've got the screen. This is the screen frame assembly. These are the access doors. The product will come in through the top. You have swinging hammers on the inside, and the product will discharge out of the bottom. But once again, the screen is really going to be, there are some applications where we won't use a screen because the product is soft or it's wet, especially in a hammer mill. Maybe it's sticky, maybe it's like a sweetbread or pan dulce. We try to design these specific for what the customer's needs are. So screen types, let's talk about them. Generally, most people use or are familiar with what we call a round hole screen. They come in lots of sizes, and for the most part, they have a higher open area. So when we talk about open area, we are talking about how much open area is with the hole. So maybe on a 30 mesh round hole screen, we might see 34% open area or 50% open area. That means if something is going to do 100 cubic feet and we add this screen in, it's only going to do 50 cubic feet. So the screen does hold up some of the capacity in certain applications. But once again, round hole screens have a higher open area. Some other specialty screens that we use are what they call a triangle or a cheese grater screen. These are directional. They have a special punch. So if you look, this is flat. And if you look at this one, they actually have raised pieces. These are raised almost like for something to grate or sand. We use those for stronger products, things that are a little more solid versus friable, and they are definitely designed with direction. When we look at screens, when it comes to milling, we talk about screen types. What are the sizes? What are the openings? What are the shape? And are there any raised or directional edges? But other things that we look at are how thick are the screens, because that also can change the way the mill operates and functions. When we start talking about gauge thickness, the thicker the screen, the smaller the particle size can pass through it. So I have a little drawing here that kind of shows that on a thin gauged screen, a particle can actually bounce off of one side and clear the screen. But on the same particle with a thicker gauge, it's going to have multiple movements, and sometimes it doesn't clear as easily. So if you're using a thin screen and you're getting 60 mesh out of the machine and you go to a thicker screen, you will probably get something a little bit finer, or you won't get the throughput that you were originally getting, because the product requires the same environment in order to pass through. So sometimes we use thicker screens because of wear on some products, but what ends up happening is that you might counteract the wear because the product will spend more time inside the chamber. So you might say, hey, I'll get 2 more years if I go to a thicker screen. In theory, yes, but thicker screens cause the product to stay in the grinding area longer, which causes additional wear. So you might not see 2 more years of wear, you might only see a year, and you'll have a reduced capacity during that time. So always check with the manufacturer and make sure that you're getting the correct screen thickness based on what your original system tests and setups were. So once again, like I said, the top one's the passing through off the trailing edge. The blue particle hits the trailing edge and then collides with the leading edge. So once again, you get more wear, you get a bigger opening, and you will end up excuse me, you will end up making a larger opening and getting off-spec product. Other considerations: screens usually are the first failure point. That's where, you can get, if you have moist product, you'll get blinding over the screens. If the screens aren't set properly, you might choke off some of the air, and then you'll get wear. Obviously, hole size and open area play a role, something that we've spoken about, but it also, when using it in a vacuum conveying system, will cause your fan or PD pump to operate at a higher amp loads, which can cause overheating and breaking. They don't really, screen selection doesn't play as much as a part in the ACM or the air classifying mill, because the classifying wheel handles most of that. Putting really small, fine screens like 120 mesh or 200 mesh in a mill, in a hammer mill, is a bad idea. You get way too much retention and not enough product throughput. Obviously, toughness of materials, we can coat screens to help improve with abrasion resistance. We can even coat screens for simple release in case you have something that might have a little bit of stickiness or tackiness to it. And the other thing is if you really need small screen to do the job, we might want to consider, you know, if you need a very small screen on a fine grinder to do the job, maybe going to a classifier is the right answer. Or if you need a very fine screen on a lump breaker, then maybe going to a hammer mill is going to be a better option for you. So that really talks about screens and mills that use screens. There's some other technology out there that I'd like to share with you, and they're screenless mills, or what they call attrition mills. So we manufacture a rotor mill, and what this is it's an attrition mill. It's capable of grinding wider varieties of products. I don't know if I would use the word heat sensitive because there is a very high delta T, but these are made for larger capacity throughputs and abrasive products. So we make these all the way up to 1,000 horsepower, 25,000 CFM, and we can armor them for more abrasive products. There are no screens. Basically what it is it's known as an attrition or a long gap mill. So there are no screens that choker wear. It's very simple to maintain. And then we can also offer an optional flash drying. So we can add heated air to this process in order to dry moist materials like distillers grains and things like that. That need to be dried and milled at the same time. So some things up to 40 to 60% moisture, depending on what it is. If we can get it to flow into the mill, then we can heat it up, flash dry it, and mill it. So how does it work? Well, you've got a couple things going on in here. In this picture, you can see rotors with blades. And then on the door, you can see what they call a corrugated liner. So the product comes in through the bottom, it's dispersed, it's ground up through the outside of the chamber, and then it removes from the top. So here's how it actually works. Once again, we're still working rotor stator. So you have the housing or the body. You have inside the body a corrugated or raised liner. These can be made out of AR400, ceramic, any other materials that will help improve the life, whether it's abrasion resistant or heat of the unit. And then on the inside, you have a rotor that's turning, and then you have the blades. The space between the rotor and the corrugated liner is the grinding area. So this open area is where it is. So the way it works is that the product comes through the bottom, and this is looking from the top down. These fins push the product up against the corrugated liner, and as the product comes back out, it's hit by other pieces of the product and the fins. So basically the product is helping grind itself, or that's what we call attrition. So that is how the attrition mill works. The product is using itself, and the mill is generating the environment to cause the product to, once again, hit the corrugated liner, which the product will break, and when it hits the blade, it'll break, but also when it hits itself, the turbulence internally of the machine will help it grind the product. So that's how it looks from the top down. So once again, you've got the corrugated liner, you've got the rotor with the blades, and you've got the body. And once again, the product comes in, it goes up along the sides of this, and then comes out through the top. The good thing about this is you don't have to take it apart to service it. It's very simple to service. And you can do multiple grinds and or cuts, multiple grinds with the same unit by changing the airflow and the speed. So how does that work? Normally on a typical grind, we might run 900 RPM on one of the larger units, or maybe 2,700 RPM, and have a certain amount of CFM that gives us what we're looking for. that's the target grind. But once again, maybe you might have an opportunity to sell a higher priced version of the same product as a finer grind. So what we end up doing is we increase the rotor speed and we decrease the airflow. So as you can see here, for a finer grind, what we do is we have the rotor turned up and the air turned down, which gives more resonance time inside the grinding chamber. So the longer we can get that product to continue to move through the chamber, but as slow as possible with a higher RPM, is going to give us a finer grind or polvo más fin, right? The opposite of that also holds true. If you need something that isn't as fine, you can increase the air and decrease the RPMs and get something that's a little more coarse, more not as fine. So you're increasing the air to reduce the amount of resonance time inside the grinding chamber. There's a lot of other mills out there that work without screens. Usually the two are attrition mills, like you see here, the rotor mill, and then the others would be media mills, which most people are familiar with, something like rod or ball mill, which have a tendency to be batch type mills. This is a continuous operation mill, so it's a little bit different than a media mill. But all three of those, both those types of mills, ball, rod, and attrition, do not use screens in order to manage particulate output size. They use resonance time and airflows, depending on what type of mill it is. So that would be the theory of operation on an attrition or a rotor mill. So in review, from reconditioning to particle reduction, there's several ways to achieve a target grind. Most mills consist of a stator and rotor combination with screens for oversized particle retentions. Mills with built-in classifiers offer you a tighter particle distribution curve for firing particles, and screenless attrition mills offer multiple grinds by changing speed and resonance time in the grinding area. Screens can be designed and applied differently to manipulate a mill's output and the product's characteristics during the milling process. I will say this, the best way, always the best way to verify that we're using the correct equipment is to schedule a test and make sure that the output meets the requirements. And I can say that we have had instances where we look at a product and we say, yeah, absolutely, that's easy to mill. And then when it shows up, it's not the same. When we go to test it, what we thought would work wouldn't work. So it's always best to make sure that we get a chance to do some sort of test or clarify what the product actually looks like by getting a liter or two at our facilities. And we do offer a full testing facility at PRATER in Bolingbrook, Illinois. There you go. You said 40 minutes, Rafael.